Everyone, and welcome to day 2 of Arab MTech Conference and the Startup Conference. It's my pleasure to host this session, and this session will be presented by, recorded and presented by Mr. Tan Chen Hu, and he will present. It will present a brief introduction to ICS CyberSecurity. If you have any question, please complete the feedback form and send it to us, and we will get back with an answer. Thank you.
Good day, ladies and gentlemen. My name is Chin Hua. I'm the Division Manager for Industrial Control Systems Cybersecurity in ST Engineering. It is indeed my pleasure and honor to be here today to share with you on my presentation, Cyber Ready for OT Systems. In this presentation, I will touch on the impetus for OT cybersecurity, what are the potential intrusion points, what is our approach and deployed solution, and last but not least, the use case. So, what are the impetus for the change? Essentially, there are 2 to 3 main reasons. Firstly, the threats are real and coming fast. These are just some of the attacks that happen over the years. Typically, there are 2 sources of threats, internal and external threats. The Stuxnet attack back in year 2010 is a classic example of an internal threat, where the employee actually plugged in an infected thumb drive into the OT environment. Subsequently, the malware took control of the assets, and thereafter it varies the gas separation device at extreme rotational speed, causing it to break down. The Black Energy malware attack on the Ukraine power substation in year 2015 is yet another example, but however, it is a case of an external attack, whereby a phishing email was actually sent to the employee. The employee clicked on the attachment, the malware was installed in the IT environment. Subsequently, the malware traversed from the IT environment to the OT environment. But back then, the hackers has yet to learn how to control the power substation. As a result, it remains in the stealth mode for a period of about 6 months, whereby it learns the behavior of how the operator controls the power substation. Thereafter, apart from harvesting the credential of the customer and at the same time flooding the call center, the hackers does a few main things. These include taking control over the engineering workstation, shutting down the power substation, and at the same time, shutting down the Ethernet to serial gateway, which is used by the engineering workstation to communicate with the power substation, thus resulting in a few hours of outage in the western part of Ukraine. Fast forward to year 2020, there are also numerous attacks on the critical information infrastructure. These include water treatment plant, attack on the US natural gas facilities, manufacturing plants like the car factories, etc. Secondly, to further complicate the matters, OT is typically more challenging than the IT environment, simply because of the fact whereby OT controls the physical world, while IT manages the data. When it comes to OT system, it can have dire consequences on the critical infrastructures, services, environment, and even human life. Coupled with the fact whereby countries are moving towards a notion of smart nation, gone are the good old days whereby our life will be the same. The quality of life, the way how we manage our life will be different. There will also be Industrial Revolution 4.0. This is where IT and OT will converge to reap the benefit of productivity and efficiency. As such, gone will be the good old days where OT system will be managed as silo. At the same time, cybersecurity professionals have very little knowledge on the OT environment. And likewise, the control engineers have very little knowledge on the cybersecurity as well. This is a gap where we need to address. Next, I will touch on the potential intrusion points. This is a simplified representation of how a OT and IT network are being connected. To the left, we can have vulnerability due to vendors who do remote access login to do maintenance, or perhaps due to COVID-19, it could be our employee or staff who do remote access login into the OT environment just to do monitoring. The vulnerability can also come from the internet, subsequently move from the IT environment to the OT environment, which I mentioned earlier on just now, in which the Ukraine power substation is a classic example. Last but not least, human being the weakest link. It could also be our employee or staff who plug in an infected thumb drive into the OT environment. But whichever is the case, the malware will subsequently gain control of the assets and to cause the industrial control system operations to come to a halt. So, what is our approach and deployed solution? In order to protect against cyber threat, we need to know what assets that we have and how do we design our network topology before we design and implement our cybersecurity solution alongside with our cybersecurity policy and standard operating procedures. In short, SOP. Essentially, we can follow the NIST guideline where we identify, protect, detect, respond, and recover in conjunction with the CIA-SAM and the AAA guidelines. Here, when we talk about CIA, the C refers to confidentiality of the information, I refers to integrity of the data at rest or at transit, A refers to availability of the information when needed. As for SAM, S refers to safety of the plant, environment, and human life. A refers to availability of the services. M refers to maintainability of the plant. Last but not least, when we talk about AAA, essentially we are talking about authentication, authorization, and auditing. Based on the vulnerability as highlighted in the earlier slides, essentially we can put in place a VPN and a firewall to control the access of who gets into your OT network. We can also put in place an ICS which will monitor the OT cyber health status of your OT network. This ICS is also known as Intrusion Detection Monitoring System. We can also put in place a smart probe whereby it will collect all the OT network traffic and to pass it to the ICS for the purpose of analysis. We can also put in place a data diode which will only allow information to flow from the OT network to the IT network and not vice versa. In the IT network, we can also put in place black computers and discrete in order to provide an entire holistic solution for your OT and IT environment. These are just some of the examples. Here, the core components will be on the ICS, augmented with level 0 monitoring capabilities, which I will elaborate more in the subsequent slides. This is a simplified representation of the OT environment where we have level 0 all the way to level 4. Within level 0, we can have turbine, motor, valves, actuators. Within level 1, we can have RTU, PLC, and level 2, we can have HMI, so on and so forth. Essentially, within the OT network, we will need to identify the core switch in which all the network traffic will pass through and to spam this core switch. Thereafter, the spam traffic will be collected by the data collector, which will in turn pass it to the ICS cyber analysis platform. This ICS cyber analysis platform is also known as the ICS, whereby it will do asset discovery, learn the behavior of the OT network, and also at the same time to allow policy to be input into the system by the operators. When it comes to the asset discovery, it will provide information like how are the OT devices connected in the OT network topologies, which are the devices that can be found in the OT network, information like IP, MAC address, and even the firmware and the brand of the OT asset can also be provided. Thereafter, it also provides the vulnerabilities associated with each of the devices. In the case of learning the behavior of the OT network, take for example, during the learning phase, we have PLC 1, 2, 3, 4, 5. During the learning phase, PLC 1, 2, 3, 4, 5 do not talk to one another. But however, when it is being put into the detection mode, and due to cyber threat, PLC 1 and 2 starts to talk to one another. This is where the ICS cyber analysis platform will detect the change in the behavior in your OT network and to flag out the alert. And this alert will also be sent to the SIM. From the operator viewpoint, operators can also configure policy in which they can set the day and time of the month to allow the vendor to do remote access login and to ensure compliance. For non-compliance, assuming the vendor does not log in within the specific day and time of the month, an alert can also be flagged out. But however, there is still a problem. Implementing the ICS or the ICS cyber analysis platform, it is not enough. Why do I say so? In the case of the Iron Gate malware attack, the hackers can send commands to the PLC to get the industrial boiler to keep on increasing the temperature. And at the same time, to send information to the HMI, telling the operators that the temperature is constant over time. Over a long period, the industrial boiler temperature will keep on increasing to the stage whereby it will break down, resulting in a halt of the operations. This is where we think that level 0 monitoring will be required. Here, when we talk about level 0 monitoring, essentially we are talking about the electrical parameters, such as voltage and current. A component, or rather a sensor, will be placed in between level 0 and 1 to monitor the behavior of the voltage or current, and thereafter that to flag out the anomaly. Take for example, during the learning phase, there will be a minimum and maximum threshold being set, in which suddenly due to cyber activities, it exceeds the minimum or maximum threshold. This is where the alert will flag out. Okay, this is just another representation which I showed earlier on just now. Essentially, the level 0 monitoring is integrated with our ICS, whereby this ICS, apart from being able to monitor the network traffic, and at the same time, it is also able to provide level 0 monitoring. Here, I would like to emphasize that when we talk about level 0 monitoring, essentially, it is just about monitoring the electrical parameters, which is voltage and current. So what is our use case? Allow me to share with you more in the subsequent slides. When it comes to OT cybersecurity, there are a lot of solutions out in the market, be whether it is from our solution or even from the competitor solution. It can be used for power generation, power transmission and distribution, oil and gas, renewable energy, transportation, be whether it is for aviation, maritime, or even rail. It can also be used for water and wastewater treatment plant, manufacturing, factories, and last but not least, building management system. Last but not least, before I end my presentation, do feel free to contact the organizer or partner or drop me an email should you have any queries. Once again, thanks for having me here for the sharing today. Stay well, stay safe, and have a good week ahead. Bye-bye.
Dear attendees, please note that this is a recorded session. If you have any question, please complete the feedback form that I added in the Q&A, and I will add again for your information. And send it to us, and we will get back with an answer. Thank you.